Welcome to today's tutorial. We'll be we'll be doing 2019 exam memo, right? So the way I'm going to structure this paper, I'm going to start with the most difficult, the most challenging one, which is the DLL question. Then we're going to go back to question one, which is the UML. So the DLL is a bit tricky, right? So we need to define the DLL. So let's do that. So what is a DLL? Um, we need to understand what a DLL is first, right? So so a DLL is something called a dynamic link library, right? So DLL stands for dynamic linked library, right? So, so there's two types. It's called a library because it's shared, right? So shared meaning like, for example, when you go to a library, you share books, right? You can, I can go to the library and then access that book, and then I put it back. Then someone else comes the following day to access the very same book. So we are sharing that book. And if you can think about it in that using that analogy, right? You can see that a DLL it works in such a way that you have one copy. So by one copy, we we are trying to save memory and space, right? So we're gonna use the dynamic library to do that. So meaning that a dynamic library that helps us to save memory and all that, right? So there is also a static library which which um which is pretty much inefficient because it is linked to your program. Even though this is called dynamic linked, right? It is still linked to your program, but it's not linked at compile time. So a DLL is linked at load time or runtime. So basically when your application is actually running, that's when the DLL is linked, right? Which makes it more efficient because if you have to make changes in your DLL, you only have to recompile the DLL, which improves things like maintenance, right? Maintaining your code. The maintenance will become a bit faster. So let me make an example. So let's say you have let me put it this way. Let's say you have an app, right? An application, whether that's an application like WhatsApp or Instagram, think of it in that way. That's what I mean by application. So imagine this is your app, right? So this is your app. So let me explain both of them, right? Static and dynamic. So there they are, right? So we have two apps. We are using the two different approaches, right? One is using the static, the other one is using the dynamic linked library. So I would have to add a comment on top, or so let me do this to do. So let me just do that. So let me enlarge this. So this is static linked library. So this is an example of static linked library, right? And then this would be an example of a dynamic linked. So it's dynamic linked library, right? So there they are. So let me choose different color to do. So we have static and dynamic linked, right? So static, um, the way static works is that at the code, right? So what's the whole point of DLLs? DLLs is basically to extract smaller programs and then integrate them or link them. That's the term link, or link them to existing bigger programs. So for example, I have an application that, so for example, I have an application that, so I have an application that, what is this? So for example, this application calculates the distance, right? So it's calculating the distance. That's the smaller program, right? The bigger program is that I want to draw a circle, something like that, right? So in order to draw a circle, I would have to go through each pixel and then check the distance of the current pixel from my circle center. And then if that distance is less than or equals to the radius, then I keep drawing the coloring the pixel. Hence, it ends up drawing the circle, right? So the full program or the bigger program is just drawing the circle, but the smaller program is the distance function, right? So hence, I extracted and I want to make a DLL whereby this function will be added or linked to the bigger program. So that's the whole point. It also makes our application smaller. Imagine going to Google, or is it going to Play Store or or the App Store for the ones using iOS. Imagine going to the App Store or Google Play Store and then you try to download an app and you find out that it's very big, like 2 gigs of space, and it's a simple application. Let's say it's a calculator. Imagine downloading a calculator that's 2 gigs of memory. It's too big. Hence, we use DLLs to reduce that memory, and it has a lot of benefits, right? Those are one of the benefits. It can reduce the memory being used. Since you're not saving everything into that one file, you're creating smaller programs or taking functions and putting them aside and then linking them when the application actually runs. Hence, hence we say it's linked at runtime. With static linked, it's linked when you're compiling, when you build, when you make the executable. So this is static linked. So I'll say this is the static. So I'll say this is the static DLL, right? DLL. So this is static DLL. So the way it works with static DLL, like I said, it's compiled into each program. So therefore, each you can imagine as this in a way that it's like each program has its own copy, right? It's like, for example, imagine if the library, imagine, and I don't, it's not the case, but imagine if the library was like that. The library, you were able to like, so for all students, imagine how big the library would be. Book. Remember APK or or the University of Johannesburg, right? In full, it's around 55,000 students, right? Imagine each student had their own copy of the book in the library. You can imagine that's just one book. That means I would need 55,000 books because each student will have their own copy. That's static link library. You see that you're wasting memory. You're gonna need you need to create the library has to be as big as as Mall of Africa. Because I mean, if each student has their own copy and there's around 55,000 students, that's a lot. That's a lot of space that's going to be used. Hence, DLLs, okay, static, it's not static DLL. My bad, it's not static. Can just say static library. DLL stands for dynamic link library. So I can't say that. So it's a static library. And then here it's the DLL, right? The actual DLL. So let me use a different color. So let me click here. So I hope it's becoming somewhat clear to why we need the DLL. So with DLL, right, you can have an application like this, right? You see, so let me actually let me add at least 3 copies, right? So this is the static, right? So this is the static. And then as you can see, the static, each app has their own copy, and it's actually compiled when that application is compiled. So it's linked to the actual application. So it doesn't help in any way. The app will still be big. So we don't necessarily want that because we want our apps to we want to be able to save memory because not you know how expensive memory is. Not everyone has 1 terabyte of space inside their mobile phone or inside their phone or inside their computer. Some people have around 128 gigs. So some people have very limited memory. So with dynamic link library, right, as you can see, I can they can share, right? In Unix environment, these are called shared libraries, which makes sense because as you can see, all these three apps, they are sharing this one library, right? Which saves memory. Okay, this is not a bad diagram. It looks cute, very demure. So as you can see, the dynamic link library is shared. In other words, it's called shared library. So in Unix environment, right? Unix environment, think of it as like MacBook. You see that when you open the terminal inside the MacBook, it's using what is called Unix, right? So in Unix-based environment, right, it is called um, it is called a shared library. And it's shared library because what? It's shared. And pay attention to this keyword shared. We'll use it when we have to create things like the batch file and stuff. We're gonna use that shared keyword. So there it is. So shared library or it's called DLL in Windows, right? It's called DLL in Windows. So there it is, Unix-based environment, shared library. Yeah, so it helps us to do a lot of things. Like we've said, it helps us to reduce, or let me say, save memory, right? It helps us to save memory because we are sharing the library. Each app is not having its own copy, and it is linked at load time or runtime. So it's actually it's in it it's then DLLs are very flexible, right? They can be attached and detached um, at any time, at any point in time. That's how flexible they are. So you can add them to RAM or remove them from RAM at will, right? You can just remove them and add them to RAM at any time. That's DLLs. They are that flexible, right? Because since they're linked at load time or runtime, right? So that's pretty much the main difference between the two, right? So since we have that understanding, so let me save this image. Save as PNG. So let me go to here, and then I'm gonna say library, and then save the image. And then I do not need this anymore. So this is the dynamic link library, and that's all you have to know about it. So let me see. Yeah, there's quite a lot involved with dynamic link libraries. Hence, I decided to start with it on its own. So let's see. I hope I can remember some of the things because I'm not really familiar with creating them. So if I forget certain things, I'd have to refer back to the information on how to declare, but that hopefully I don't forget. So the way we're going to do this, right? I hope let's see. Hope I don't forget. So console application. So we are creating a C++ application, right? So this will be question what? Question 4 DLL 2019 exam. So we'll do things separately. So I'll make for this one, I have to actually create the header file so that you can see it. So I'm gonna say new, right? Go to file and then go to new and then click file and then create a header file, right? So this header file, the way I'm gonna name the header file is where this is how I'm going to sort of like build my header file based on that, right? So this is a dynamic link to calculate Euclidean distance between two vehicles. So it's something that has to deal with Euclidean, right? So I'm just going to name my header file Euclidean dot h, right? Just gonna name it like this. And then I need to save it within my current folder. I need to remove the underscore included. For this one, I advise you to make sure you don't put the underscore included. You don't have to, but I advise you to do so. So now we need to define our DLL, right? So how do we go about doing that? Hopefully I can still remember. So you say if defined, right? Um, if defined, let me see. Yeah. So if defined and then you give it a name, right? So I'm gonna call mine build. Yeah, so build underscore, and then I'm gonna copy this header file name. That's why I said you should remove the underscore included. So if defined build underscore included you underscore Euclidean underscore h, and then I'm going to define a macro, right? So the macro that I'm going to define, I need to give it a name, right? So the name I'm going to give it is, let me see, what name can I give it? You can give it any name. So since I'm dealing with the distance function, I'm going to call it distance underscore API. This name is very important. You need to have it. So I need to be able to do two things with this DLL, right? So if you check the question, they said that for to create a dynamic link library to help calculate between two vehicles. So we need to be able to load, what is this, to export, means to send it to someone else, right? To export. It's like if for those who did economics and whatever, exporting and importing, if you remember those terms, it's just exporting, it means that you're sending it to an external person, right? A person outside this domain, right? For example, if I'm in Gauteng and I want to send it to another province, so that's what we call exporting. You are sending it to exporting it to an external place. But if it's within Gauteng, then it's internal, right? I wouldn't say it's exporting, but yeah, you get what I'm trying to say. So you need to be able to export that. So basically, when I define this, right, anything with this name with distance API will be exported and imported as part of the DLL. Hence, I need to give it a name, right? I'm gonna call it distance API. You could call it Euclidean API. Let's do that. Let's call that instead. Let's call it Euclidean API. So this Euclidean API, right? It will serve as like a tag for the function. Anything with this tag, even a class, you can put that tag to say that it will be exported as a DLL, as part of this DLL, right? And imported as a shared library, right? Anything with this label here. So this name is very important. So, and this one is also important when it comes to building the actual DLL. So I've defined I'm not done yet. So I need to tell C++ that this, this needs to be able to be exported, right? Right? To be exported. So I start with exporting. You could start with import, but this is typically the structure. You start with exporting. So you say underscore underscore declare spec, right? So declare spec, I like to view it as like declare specification, right? What type of specification is it? The type of specification it is it's going to be a DLL export, right? Meaning that this will be exported like that. That's why I was explaining the export term. This will be exported, meaning sent to an external person as a DLL, right? Or as a shared library. And then else, because I need to be able to do two things, right? I need to be able to export, which is this, and I need to be able to import, meaning I need to use it or I need to receive it. If you're exporting it, right, sending it to someone, that person needs to receive it, right? So on their side, they are importing. It's incoming data to them. So this link library or dynamic link library should be able to do both. So else define um, Euclidean API and then underscore declare spec. And then I'm going to say DLL import, right? So it can be imported from a DLL. Anything with this label or anything that is this label or this name attached to it. And then once I'm done, I can say end if, so end this declaration, right? And as you can see, it appends this automatically because we are building. It's sort of like, how do I put it? It's sort of like we are defining a header file because if you see that it's similar to this, right? You see, if not defined, blah, blah, and that we are defining similar to a header file. So now we have this specified, right? We need to create our functions or the things that need to be exported. In this case, we only have one thing. You can also export a class, right? Remember, you can export a class. So I need to add this. So x1, y1, x2, y2. So it's a function, right? So double distance, right? So I'm assuming it's well, I don't know why they use doubles, but it's fine. Let's use doubles. We need to do it exactly the way it's been declared, right? So double x1, double y1, double x2, double y2, right? So remember, this is the header file. So there's no implementation at all. But the problem is if I leave this here like this, right? This is incorrect. It won't be exported the way I expect it to be exported or imported. So there's two things that we kind of need to do. The first thing is we need to put this label because we said define anything with this to be able to be exported. So I need to put this label here like this, right? So this function can now be exported, right? And imported as part of a DLL or as a DLL, right? So since that can now be done, you might be like, yeah, I'm done. I'm happy. I managed to do the DLL. I'm killing it. Well, not really. You're not really done. So, you know, in order for us to finish or wrap up what we're doing right here, we need to, there's something that we need to do, right? So in the thing that we need to do is if you leave it like this, it only works in C++, right? So it only works in C++, meaning that only code that is written in C++ can call this function. But we don't necessarily want that. Remember, DLLs need to be flexible. You can call a function written in C in a Python program, or call a function written in C++ in a JavaScript program, a totally different language, right? So in order for us to do that, C++ adds something called name mangling, right? This name mangling, right, it does something to the parameters, right, so that you can be able to do things like polymorphism and overloading, right? It, it does this thing called name mangling so that you can be able to uh, implement this function polymorphically, right? Meaning that there's many forms, meaning that there's many ways this function is defined in many ways. Just like the draw function that they've been talking about. And overloading, remember overloading is functions that have the exact same name, but they have different parameter signatures and the return type can be different. But the main important thing is that they have this exact same name. So if you leave it like that, it's mostly going to work in C++. Some languages don't have this name mangling thing, right? You can achieve polymorphism, whatever, but then it doesn't have this thing called name mangling. So we need to disable that. So how do we disable that? We disable that by putting this function within exporting it as a C function, right? When you export it as a C function, it means that you have to use the extern keyword, meaning external, right? When it's sent as an external thing to another uh to another to another app, right? It's going to be exported as a C function. So extern C. So you're going to say extern C, meaning that it's going to be exported or imported as a C function, meaning that this would disable that name mangling issue. So this will disable this disable name mangling issue, right? And then I need to finish putting that closing curly brace. And then I'm just going to indent just to make it look pretty. So now this gets exported as a C function and it's given that label so that C++ knows that, oh, it's going to be part of a DLL because I've defined this name called Euclidean API, right? You could, in theory, you could do this, which is going to be very untidy. You could do this, right? You could, instead of putting it as inside here, you could just do this, right? You could just say double and then you say extend C like this. You could do that. And then obviously you have to remove this curly brace. You could do that. That's totally fine. But we typically do it this way, just so that when you have, I feel like this is a better syntax. It's all sort of like self-explanatory. It's like, okay, export this function as a C function by disabling name mangling. Which function is this? It's this. You can add more if you want to. So this is the full header file, right? So I would say that in this case here, I would say that you have 5 marks so far. That's what I would say. But remember, we need to make use of distance formula. So we need to make use of, remember distance formula, it's the square root of x1 minus y1 squared plus x2 minus y2. No, x1 minus, now I'm forgetting. I think it's x1 minus x2 squared plus y1 minus y2 squared. And then you get the square root of that. So you see we're using the math library, right? So if you feel like you forgot, right? So you say C++, you can say C++ reference, right? To get a reference of the functions or the thing, like what basically all the functions that are inside C++, which is going to take you to here, right? You can also know which header file has what you're looking for. So remember, we need to make use of two functions to find the power, meaning this squared, right? Or you can, that one squared, it's not really a problem, but I like to use all the functions within the library, within C++, because it's been declared inside C++ because they knew that you're going to reuse it. So you can search here and say sqrt, right? And press enter. And then it's going to show you the function that you're looking for. But we are dealing with at least C++ 11 going upwards. So there's C++ 11. So you can scroll down here and you will find the thing is it sometimes show you C. We don't want C. Okay, this is C. We don't want C, we want C++. So in C++, there's the function. There's different kinds of functions, right? I'll say three. There's this one that takes in a double and returns a double. Then there's another one that takes in a float and returns a float. Then there's another one that takes in a long double and returns a long double, right? And if you check in which library this is included in, it's inside CMath, right? But this is not, I wouldn't say this is a good way to check. So I'm going to say CPP reference. CPP reference is still the same thing, but it's a better reference compared to the C++ one. You'll see what I'm talking about. So if I search the very same thing, SQRT, right? And then I just choose the CPP reference here. So you see that this one is a bit better now. You see, this is a way better. And check something at the top. It says that this is defined inside CMath, right? Meaning the CMath library, right? Basically, it was called math.h and then they renamed it to CMath, but yeah, you have to call it CMath. If you're using the float data type, you need to call the SQRTF. That F stands for float. The SQRTL, that L stands for long double. And then here you just need, as we're looking for the double one, which is this one. So I just call it SQRT, nothing more. And then I also need another function called power to find the power of something, right? So base to some specific exponent. So you see, the same applies. Power F standing for float. So if you're passing float data types or variables of type float, but we are looking for this one because we have a double, right? And it's also defined inside the C math library. So now we know which library to include. So I'm gonna come here. You can include after or before, but let's include it after, right? So let's define this, separate it, then after we can include our libraries. But we don't actually need to necessarily include it here, right? We can include it inside the CPP file. Yeah, we don't necessarily have to include it here. So let's not include it here. Let's include it inside the CPP file. So I'm going to say file and then new and then file, and then I'm going to create a CPP file. And then remember the CPP file needs to have the exact same name as the header file. So euclidean.cpp, right? And then I need to add, so now I have this CPP file that I've created. I need to select in which folder to edit, which is the current folder, which is my project folder. So I need to click save, and then I need to select all because I need to be able to debug and release it. And then I click finish, and then I'm going to include the Euclidean header file, right? So it's pretty much straightforward when you have to implement, right? Because with implementing, you don't have to necessarily specify that it's part of blah, blah, blah. You can just implement it as a normal function. So let me show you what I mean. You don't have to specify this, right? You can just omit that and implement it as a normal function. But remember, we need the CMath library in order to do this. So I'm going to say hash include CMath, right? As we found, right? So this needs to return that answer. So return, I'm going to make it very simple. I'm just going to return. I won't store it into local variables and all those things. I'm just going to return. So return, and this is all of these are part of the standard namespace, right? I'm not going to using standard namespace. For those doing math, right, this is actor, this is course, right? No, this has to be, let me just double check something. Oh yeah, I'm right. So this is, for those doing math, this is arctan cos, and then this is arctan hyperbolic cos for those doing maths 1B. So you see, computer science is actually a math degree. So if you're good in math, you definitely improve in coding. So I'm looking for the SQRT function, right? Remember, there's the SQRTF for float, but I'm looking for the SQRT one. And then the square root of what? Of x1 minus x2 squared. So it's x1 minus x2 squared. So how do I square that? I can just say this, right? Simple math times this, because that's what squared means. It means repeat that, right? Or multiply it by itself. But so what if it's to the power of 4? You see now because my code becomes long. So I have to use the power function or power function, which takes in a base, which is x1 minus x2, to the power exponent, which is like my y upper, and then squared, which is 2, right? But remember, it expects okay, it's a double, it's fine. I can leave it as 2, or I can just say 2.0. That's up to you. Either way, it'll be promoted to a double. And then x1 minus x2 squared plus standard namespace and then power function, and then y1 minus y2, and then 2 to the 2.0 squared, right? 2 squared, right? And then this is pretty much the function. So we are pretty much done with the function. Let's just build and see if we have any errors. Okay, yeah, no errors. So we kind of, let's hope we're on the safe side. We kind of on the safe side. So it's 37 minutes now. So what I'm going to do is now I need to generate the DLL, right? So how do I do that? So basically in question one, right? This one over here, you've already have your 10 marks in full. So now the important thing is doing this part. Provide the contents of a comprehensive batch file which will compile this DLL for future use. So I need to create a batch file. They did say, right? Batch file. So I need to create a batch file. So I'm gonna go to my downloads and not downloads, documents, code blocks, projects, and then DLL question for, yeah. So this batch file that I'm going to create, it needs to be within the same folder, right? Remember, this needs to be within this same folder where there's the header file. If I don't do that, we're gonna have issues. So I'm gonna right click and say new to create a new something new, whether it's a folder or whatever, but I want to create a batch file. How do I create a batch file? So I start by creating a text file, which will show me the extension, right? The .txt. You could say Microsoft SQL or Microsoft, what is this? The Microsoft Word, whatever. It's going to have a docx and then remove that docx and put .bat. You can do that. Text documents are pretty much straightforward. So in its extension is to end with a bat, B-A-T, from batch file. And then I'm going to call this run. Yeah, I'm going to call it run. And then if you change the file name extension, the file might become unusable. Are you sure you want to change it? Click yes, because you are a C++ developer, you are confident in what you're doing. So what I would do is, right, I will, let me see, I would do this. It can, by default, the echo is on, right? Meaning it can print to you what's going on. I would like it to print to me what's going on, which is good. So what I can do is I can start by echoing, right? Echoing, right, is simply me doing this. And yeah, that's what echoing does. So echo meaning print out something. Echo, remember when you're in a channel and you echo, it just mimics whatever sound you're making, right? So that's echo. So echo, what am I echoing? So I'm going to say compiling the DLL, right? I'll just say output and then I'm gonna pause. Why am I pausing? At the end of the day, I want to pause. Why am I pausing? Because if I don't pause, this is what will happen. So let me double click the page file to run it. You see, it paused, right? Because I put the pause keyword. I omit the pause keyword, it won't pause. It will just run and quickly disappear. So let me show you. So you see, it disappeared immediately. That's a problem. So I need to be able to see if everything went well. So I need to pause at the end of the day. And then after echoing, I need to I need to, so the steps, it's actually short, right? The problem is, will you be able to remember the commands? So the way I'm going to run it, right? I'm going to call G++, which is my compiler, right? And then I'm going to say minus C, right? It means compile without linking, right? Remember, we don't want to link. Remember what happens, remember when we talked about linking, right? If we allow linking, this is what we're going to have. Let me show you. If you allow linking, it'll actually become a static library because that means it'll be linked. Each app will have its own version. We don't want this linking each one to have its own. No. And remember, it's not linked at compile time. That's a dynamic linked library. It's not linked at compile time. It's linked at runtime when when your application is actually running. So therefore, when I'm compiling, I want to disable, right? I want to use this C minus C. So I'm gonna put a comment here and say minus C disables linking. So compile without linking. So I'm going to put this comment. You can check. Remember, you type rem to put a comment, right? Just like in C++, you'd say two forward slashes, but in a batch file, you type rem to put a comment. So minus C just means it disables linking because we don't want each application to have its own copy. We just want to compile without the linking part so that we can link it at runtime. So compile, and then what am I compiling? So I need to, if you remember in our header file, we defined this, right? So I need to use this, right? This, because I said if define, basically I was defining this, but this thing that I've defined, it works with things that have this label or that are labeled with Euclidean API. Hence, I labeled it here. So this is the actual thing that I'll need to use. So I need to copy that and put it here, but I need to put in a minus D there to say define this, right? This linked library with with that name, right? And as you can see, there's the name there. And then once you've defined it, you need to pass in the actual source code, right? Remember when you compile the CPP files, not the header files. You compile the CPP files. So I need to pass in the actual CPP file. And remember, the CPP file, I've called it Euclidean.cpp. And if you remember, this batch file is within the same folder. That's why I said you need to create it within the same folder so that it finds those files that you're writing in the batch file. There's Euclidean.cpp. It's right there. So, and there's my batch file. So it should be able to find it. So after I've compiled, I've compiled, it's going to generate a Euclidean, I think it's a Euclidean.o file, right? An object file, right? So let's try to run it first and see what I'm talking about. So let's build and run. So it ran that code, right? But it paused because I told it to pause. So when you go back, you see there's the Euclidean.o. So this object file, we wanted the object file. We don't want it to generate an executable because if it's an executable, that means the Euclidean is linked to the app. We do not want that. So hence, I literally want the object files. I don't want the executable files. So I'm gonna close this and then delete this. So let me delete that. So you see it's going to generate a Euclidean.o. So we now know what file it's going to generate. That's very important for the next line. And then let me also put a comment and say rem minus D just means define that linked library, right? And then we're gonna go to the next step, which is this is the step where this is the step where we actually have to define the actually creating the DLL. So you're gonna say G++. I hope I can still remember the commands. So you say minus shed, right? Remember shed. Remember what we talked about. I told you to remember these terms. In Unix environment, it's called a shared library, but in Windows, it's called a DLL. Since we are running MinchW or G++, which is not Windows, just know it's not Windows, right? Hence, we have to go and download it, but it doesn't come with Windows. G++ is a Unix and Unix-based compiler, right? So we need to use terms that Unix understands, which is shared. So this shared just means that make a shared library. So minus shared means make a shared library. Library, right? In other words, DLL. In other words, make a DLL. So it's going to generate a DLL, right? And then remember, if you check on this left-hand side, right, there's orange, right, meaning that it's not saved. From time to time, press Control S to save, and you can see now it's green so that you save the changes. If you don't, when you run the batch file, it's not going to work. So minus shared, and then I'm going to say minus O, right, to say that which output file. Remember, the minus O means output. Where are you sending this output? So minus O is specify the output file, right? Meaning, in other words, where this information will be outputted, right? Where will it output it, right? Hence I use the minus O. So I want to output it to a file that will, remember, I'm making a DLL, meaning that it needs to end with an extension .dll. It doesn't really matter. You can save it as a text file, any extension, but the problem is if you save it with any extension, there's gonna be an issue. Why would it be an issue? Because there's programs that will assume that this is actually a text file. We don't want that. So I'm gonna save it in an extension .dll, which is in an uppercase letter. So let me see if I can find a DLL here. Um, it's Windows and then System 32, right? System 32. Yeah. So there's an examples of DLLs. You can, so let me magnify. You can save it as an uppercase or small letter, but you see the way they declare, they use the lowercase letters to put the extension. So I'm gonna use the lowercase letter too, right? So going back to my code blocks project and then my question for DLL. I should have done the video, but then the thing is there's quite a lot involved in DLLs. I had to properly research. So there's what's the output file? So the output file is what's the name of the DLL. That's basically it. And then what's the name of the DLL? I'll call the DLL Euclidean dot DLL, right? That's what I'll call it. And I need to provide one last thing, right? How am I gonna generate this DLL when there's no input? Where am I getting the code? So I need to get the code from an input file. So I need to provide an input file, which is that's why I was showing you. Remember, this runs first. Remember, a computer, everything that it does, it always starts from top to bottom. So I started with the top, and then it echoed, and then it went down, and then it compiled here. What was the significance of this step? We wanted an object file, which is the .o file. So that would be that so that we can use it here in this step as our input file. So I'm gonna remember it was called Euclidean.o. Why was it called Euclidean.o? Because this was called Euclidean.cpp. So this will be the input file. It will take that thing and then put it and store it inside this file named DLL, Euclidean.dll. Then I think this should suffice. Yeah, I think this should be fine. but there's that one last line that we need. So let's put that one last line. So you need to say minus WL, comma, and then you say minus minus out, implib, right? So then the minus WL just says that send this information to the linker, right? So minus WL just means send, not this information, send these flags to the linker. So that's the last step. We need to send the flags to the linker. Output file, and then the last thing we're gonna need to say lib, right? And followed by, I think it's our DLL name, right? Yeah, which is this over here. Yeah, it's a DLL name. So I'm gonna say Euclidean lib Euclidean dot A, right? So it's the WL sends these flags to the linker, which is the output implib, and then this file over here, lib Euclidean.a. So that's pretty much all you have to do with the batch file. That's pretty much this is where the other 10 marks comes from, right? So I'm going to run the batch file. So let's double click and see if we have an error, right? So sends to the linker. So as you can see, it doesn't know what WL is, right? I would have to actually, so let's see. Yeah, it could, but it did manage to create the DLL, right? But I need to fix this issue, right? The WL issue, right? This is the first time working with doing DLLs, right? Like this, right? So bear with me. I didn't set up all this settings. So, um, okay, so let's see. Mm, it's not WSO, it's WL. So let me just ask ChatGPT. I don't know why it's not so check ensure that use a compatible toolchain. If you're on Windows, consider using a toolchain that supports Unix style commands such as minhw or cgwin. I did have minhw installed though. Or maybe it wants me to run. I guess it's the compatibility issue. Yeah. So use it's a compatibility issue. So let me try it again this way, right? So let me close, but we do have the DLL. It's just in a small error that we have. So I'm gonna copy this path. Let me see if I still have that. Remember that terminal that I told you guys to install. Um, oh, I ended up did I remove it? Okay, I didn't. But I also have Ubuntu, right, which is Linux, right? So I can also use that. But the problem with this one is to move to C drive, you have to say cdmnt, right? Um, okay, seems like oh, cdmnt / c, or it's not the case. Is it? But it's mnt some. So it's cd mount. Hmm. Okay, let me try. Let me see if I guess I have to use the. Oh no, this is what am I doing? This is not Ubuntu, man. I'm not in Ubuntu. No, this is Linux, Unix based. So since I'm not in Ubuntu, I'm not running an Ubuntu terminal, meaning a Linux terminal. Okay, so now I deleted this. So I'm gonna copy this and then paste it here. And then remember, you need to use forward slashes. But remember, since this, if you look at this name, right, it has a space in between it. So it's gonna cause problems when it actually looks for the file, for the folder. So I need to put it in double quotes so that it sees it as actually one string. You see now, I made a mistake. I forgot to put the opening um so M says two. So CD, let me put it before I forget it. Okay, so this thing tends to forget a lot. So hopefully now it will not have that error, right? So put the double quotes, then change every backslash to a forward slash because this mimics a different operating system, right? Then there we go, finally. So there's everything. So I need to run the batch file, right? So dot backslash run dot bat. No, is it forward slash? But it has to be backslash. Okay, forward slash. I'm mixing the two. Okay, WL is not recognized as an internal. Yeah, it's still not picking it up. I honestly don't know how to fix that, but it says that it's a compatibility issue. Let me try Ubuntu, but everything is fine. We have the DLL. You've answered the question. I'm just doing extra things to make sure that we don't have any warnings or errors. So let me do this. So this, you could have attempted the DLL bonus, but that's for next year's first years. So I'm gonna CD into mount C drive. So now I'm in the actual C drive, right? And then I'm gonna move into, so let me do this. Okay, C drive, users, OneDrive. Okay, so I need to go into users. So CD users, right? And then the users, I need to move into data, and then I need to move into OneDrive. Mm, don't I have users here? Yeah, there is users. Okay, so CD, let's start with the users. How can you say no such file found? Because I'm actually mission denied. Mm, yeah, it's fine. Let me not try to complicate things, but it is fine. So let me refresh. So there's our DLL right here. If you try to open the DLL, right, remember it's in machine language, right? You cannot read it, but we can use this DLL, right? Which makes our coding easier. We can just use this DLL to import it and just run and call the function from this DLL. So that's pretty much all you have to do here. So that's pretty much all you have to do in question 4. Then you get the full marks, so you get 20 out of 20. I would do another past paper where we go through the process of actually calling it, right, inside your main.cpp, whatever. So you create the DLL, then you call it, then you use it. So I will go through that in another past paper. So I'll let me see how long the video is. Okay, it's an hour. Let me see. Hmm. I could try to make it let me just leave it like this. I don't want to because I know the attention span or the way the brain works, right? Around 30 minutes to 45 minutes is the maximum for the brain to comprehend. So let me stop the video here because this is something new, right? You haven't been doing DLLs for a while. So let me leave it here. I'll continue. I'll start a different video for the other questions. So I hope it makes DLLs now make sense.